Hi Bobcats, this is Ms. Lee, and today's video lesson is writing two-step linear equations from tables. So we've already written one-step linear equations from tables, and now we're going to move on to two steps. We've talked about two-step equations before. We've solved two-step equations, okay, just regular one-variable equations. Two steps have a constant, some number that you're adding or subtracting, and it also has a coefficient, a number that you're multiplying or dividing the variable by. So that's what we're going to be dealing with the two-step linear equations. So make sure as you're watching the video that you're taking good notes. Okay, so this is a 7th grade TEK, and it can get kind of confusing because they use different terminology. In Texas, that means the same thing. Okay, so we've just talked about the two steps that the linear equation can have. We know it's going to have the two variables, the y and the x. We know the x's are independent, and we have to use it to solve for the y, which is the dependent. So one of the equations you can use is called y equals kx plus b, where the k is the multiplier, it's your coefficient. And sometimes the k represents the constant of proportionality. And the constant of proportionality is a ratio that describes the change in y in relation to the change in x. So we call that, to find the k, we call that delta y, which delta is like a triangle looking symbol, and it just means change. So the change in y, or delta y, over delta x, the change in x. We write that ratio, we simplify it, and boom, that gives us our coefficient. That gives us our constant of proportionality. At other times, the constant of proportionality can also be called the rate of change. And it is written in the form of y equals mx plus b. So instead of using k as the coefficient, it uses the variable m. And m actually stands for slope. Some of you maybe have heard the term slope from older siblings or from your parents. Okay, slope tells you the movement. How is x moving along your equation, or along your graph, your linear graph? And then b, which is our constant, that's your beginning amount. What are you starting with? We're starting here, and then this is the movement we're going to make from here. So again, you could see it with the k for constant of proportionality. You could see it m for rate of change. Either way, it's the coefficient to your variable x. Okay. Actually, I kind of already talked about this, talked about b being the movement, but the b is actually called the y-intercept. And it's called the y-intercept because it is where the line of the graph crosses the y-axis. If it crosses at the origin, which is 0, then there is no beginning amount. If it crosses someplace else, like here, it's crossing the y-axis at 2. So this would be plus 2. That would be your b. That's your y-intercept. All you have to do is think, oh, b is my y-intercept. What does y equal when x is 0? Because if you look at your graph, it doesn't matter where it crosses on the y-axis right here. It's going to be at 0 for x, isn't it? Okay, let's put all of this into action and see what you think. We have the table that represents the diameter of a tree in inches, y over x years. So make sure you do know your independent and your dependent. Here it's been told for us. Time, of course, is always your independent x, and then the diameter would be y. First thing you want to do is you want to find your rate of change. We're going to write it as a ratio. This is your coefficient. This is the m that we're trying to find. So let's write it. The change in y, and I always want you to set it up, change in y over change in x. And it's kind of backwards. You would think x should go on top, right? Because x comes first alphabetically, but nope, that's not how it happens. Y is the change in y first. So looking at your table, you're going to choose any two y values that you want to. I'm just going to stick with the first two, 10 and 14. And I'm going to say, okay, well, how did it change? How did it go? What kind of change was made from 10 to 14? Well, it's increasing, so it's a positive, and it increased by 4. So the change in y is a 4, positive 4. Do the same thing for the x. Find the change in x. You want to choose the same two positions in your table as what you chose for y. Since I chose the first two numbers in the table for y, I'm going to choose the first two numbers in the table for x. I'm going from 0 to 10. It's increasing, so it's a positive. From 0 to 10, it's increasing by 10. So it's a positive 10. So our rate of change is 4/10. And then like with any fraction, simplify. I can divide both by 2, and I get 2/5. That is your rate of change. That's your m. Now, the initial value, this is your b. This is your y-intercept. Okay? What does y equal when x equals 0? We'll look at the table. We're lucky because we have x equals 0 in the table. And when x equals 0, what does y equal? 10. That's your y-intercept, your initial value. Initially, you're starting at 10. And now you're ready to put together your equation. We're using y equals mx plus b. You can also think of this as y equals kx plus b. The x and the y stay the same. You don't change them. You just rewrite them. Y equals, it's the k or the m that you replace with a coefficient, the rate of change, which is our 2/5. The x will stay at x, and then we add our initial value. We add our y-intercept. Because it's a positive, you are adding 10. So this is your equation. Y equals 2/5 x plus 10. Okay, if you're a little confused, pause it, rewind it, listen to it again, or let's move on to the next one. Okay, we have another table. This time our table is vertically. Make sure you know your x and your y, your independent and your dependent. Total cost, total is always your dependent, that's your y, which means the number of games is your x. First thing you want to do is you want to find your rate of change. Change in y or delta y over the change in x or delta x. Pick any two y values. And I'm going to do a little bit differently this time because I want to deal with whole numbers. I really don't want to deal with decimal numbers. So I'm going to pick this 12 and I'm going to pick this 19 and I'm going to find the change between the two. I know I'm increasing, it's a positive. From 12 to 19, it increased by 7. So it's a positive 7. To find my change in x, I have to use the same positions. Since I used the second position in the table for my y, I have to use the second position in my table for x, and then the last one. So I'm going from 2 to 4. What is that change? It's a positive 2. So this is my m, or this is my k. We're using this equation. This would be the coefficient to the x. I'm multiplying x by 7/2. My initial value, this is my b. This is what is the value when x equals 0. Well, if I look at my table, unfortunately, I don't have 0 on my table, but I can add the 0, can't I? So I can put my 0 here, and now think about it. What is the change from the 850 to the 12? When x is increasing by 1, how much does y increase? Well, it increases by 3.50, doesn't it? If I go from 2 to 3, it's increasing by 1, and from 12 to 1550, it also increases by 3.50. So now let's go backwards. Instead of going from 1 to 2, let's go from 1 to 0. This time, I'm decreasing by one amount, right? So instead of increasing by 350, I'm going to decrease by 350, right? Which is going to give me 5. So when x equals 0, our y-intercept, or b value, is going to be $5. And now we can write our equation. Okay, y equals m, or k, our coefficient, which is 7/2, x, plus our b. What is our b? 5. There's your equation. So sometimes you might have to go and find what y is when x is 0 in a table. Sometimes you'll already be given that value. Or sometimes you might have a graph and you can figure it out from the graph. Okay, so I want you to pause the video and do this next one on your own. When you're done, come back to check to see how you did. Okay, did you get the equation is y equals 3x plus 15? If you did, awesome, awesome job. If not, let's go through it really quickly. So again, we want to find the rate of change, the change in y over the change in x. I use the first two values in the table. Make sure you do x first, not y first. I'm sorry, make sure you do y first, not x first. So the change in y going from 15 to 21 is a positive 6. Use the same two positions in your table for the change in x. Going from 0 to 2 is a positive 2. Make sure you simplify. You get 3 over 1, which simplifies to 3 whole. That is your m. That is your coefficient to x. Your initial value, your b. What is y when x is 0? Well, luckily our table already has the value. When x is 0, it tells you y is 15. So that is your y-intercept, your b value. And now you're ready to write your equation. Y equals, replace m with that coefficient of 3, so 3x, and replace the b with that constant of a positive 15. Y equals 3x plus 15. Okay, good job, Bobcats.